Hello, here's Xavier, and today I'll talk about the structure of SMR-2, all the process, the design process we had. I'll start by talking about the shape. Basically, the structure is divided into three sections: the nose cone, the computer, and the engine section. Each section has its particularity. So the nose cone is 50 centimeter height and have a radius of 10 centimeter. That's where the parachute is and the battery also. Um, Basically that's where all the parachute ejection process is will be. And there's also a nose cone top that will be able to just sit on top of the nose cone. Uh, when the parachute deploy, it'll be pushed out of the nose cone, and we'll don't need tape or anything to the nose cone top to sit on the nose cone section. After there's the computer section that is uh, 15 centimeter 8. The nose cone section, that's where the computer section. Sorry. So there's the computer section. That's where uh, is the computer, and it's 15 centimeter 8. This section is pretty simple because it's just hosting the computer. There's nothing to see. Um, and there's the engine section, where is the TVC, and I'll talk about the TVC a little bit later, but this section is was very uh, complex to design because of the TVC. So the TVC was very hard to design because there was several requirements, it has to be resistant, resilient. It has to be flexible between the two mount X and Y. Uh, and that's why at the beginning we did a first version of the TVC mount that only had one axis. And at one axis, it's obviously very simple to do. Uh, we had some problem to actually do the place where the servo is sitting, but we managed to find a way to actually have a good measurement. So after we did a second iteration including the Y mode, but clearly it was too weak, uh, so we had to redesign another time, and this other time wasn't still working. So we did, I think, three major versions of the TVC mount before having our final mount that is now working. The most things we had to care about is that we want to have the engine centered. Um, centered. So yeah, we had to take the exact measurements, and like we when we modelized, we basically modelized Y and X in the same Blender file. Um, that's one of the reasons why we might switch to Fusion 360 for SMR-3. Um, so yeah, that's basically for the TVC system. Now I'll go into the I'll go into the biggest part, that is the computer. So now the computer was one of the most hard things we had ever did in the SMR2. It took us so much time. It is insanely complex. SMR 2 ads was supposed to have LLC as a flight computer. Uh, the LLC was like only a breadboard with a component soldered and wire. The problem was wire were detaching very often, and a lot of components were not working as they were supposed. And one day, the the actual board, Arduino Nano, just stopped working, and yeah, we were very near from launching SMR-2. So basically, what we did is that we uh, go for a PCB design where it's basically one board that is designed for the components that will be on this, and it saved us a lot of time actually. It was very much more easy to uh, solder on this according to Fruit Loop. Um, so yeah, uh, this was hard because there was a lot of new components, and the thing is that we can't easily uh, remove parts if something is not working and as intended. So yeah, that's basically the main concern. And well, there's things that are waiting that has to wait until we really test it to be confirmed. So if like we fail those tests, it will be very sad because it means that the computer was not. I didn't design it well, but I think it'll go. It will be good for this. Pioneer as the Arduino Nano as microcontroller. It also have a buzzer to be able to communicate with it. I mean, listen to it, know what is the current state. We have a flash chip to recover the data from the flight. We have an MPU 6050 to actually gather the rotation and the angle of the Pioneer and the old rocket as well. Uh, we have the BMP 280 to know what's the altitude of the of SMR-2. And we have one switch, we have one battery port, and two pyro channel, one for the parachute ejection charge and one for the engine ignition. Uh, yeah, basically the computer will be able to auto-ignite the engine. We also have six servo ports. However, for SMR-2 flight, we'll only use two of them because we had some issue and the Arduino will not support uh, six servo ports. So yeah, flaps will not be controlled, sadly, for this test. So after having designed the computer, we soldered a component on it, and then I code some tests. Uh, Compared to LLC tests, uh, Pioneer was very much more. It went very well than much more well than we expected. Uh, so yeah, the buzzer is working. MPU is. We have some issue with the MPU, but we just fixed it, and it's with the TBC, it's 100% working. Um, we didn't test yet the pyro channel, but I think it's supposed to work. Um, the Bluetooth, yeah, we had a Bluetooth antenna also, but uh, as the testing for this is not successful, we'll just skip this. because the flagship is working, and there's been 6 months as we're working on this, so we just want to launch as soon as possible. Um, we also had a lot of the issue with servo, but it's now fixed. So we had issue also for the flagship, but it's now working. So yeah, that's nice. Um, so that's all for the test campaign of Pioneer. So now let's get into the TVC code. Actually, the TVC code is basically very simple. It's taking the X orientation and transmit it to the X servo, uh, and same for the Y servo, but it's not taking the Y rotation, but the Z rotation of the computer, because our computer is not uh, sitting like horizontally, but vertically into the racket. So that's why. Um, so that's all for the computer. So now let's get into the TVC code. Actually, the TVC code is basically very simple. It's taking the X orientation and transmit it to the X servo, uh, and same for the Y servo, but it's not taking the Y rotation, but the Z rotation of the computer, because our computer is not uh, sitting like horizontally, but vertically into the racket. So that's why. So that's all for the computer. Now I will start talking about what's to expect for the test campaign. So yeah, that's nice. So basically, the next test we expect to do is actually parachute execution test. The static fire test and the launch. That is not the test, but it's actually the actual launch. So yeah, thanks for hanging out, for watching this video. It's very nice to have your support, and we will be able to launch very soon. We might start in actually 1 to 2 weeks a test campaign. It will be streamed on our Discord server that will be in the description of the video. So yeah, thanks for following us, and hopefully we'll see you soon. Have a good day.